Um, okay, so let's look at a few other flavors of things. Up to now, one of the chops, trail, is actually 4 seconds worth of samples, and the chops that have the horizontal bars are almost one sample long. If you middle click on any of them, you can see that the the chop is like, if you look at this number here, you can see it says 1 eye or one sample long, sometimes 2 samples long. The trail is 4 seconds long. You can see 0 to 4s. So it basically builds a channel starting from time 0 to 4 seconds. Its equivalent is 240 samples and 240 frames. Down here is the sample rate, and let's actually get in a bit closer. It's 240 samples long, whereas if you middle mouse click on these things, it's 1 or 2, so very short. So chops, one of the attributes of chops is how long they are, and their length is expressed as time, and if middle mouse click here again, it's time 4 seconds, or 240 samples or 240 frames. So samples and frames are slightly different from each other, and I'll show you why with audio in a second, but as it turns out right now, this chop is set to be 60 samples per second, which is our default, because down here on the bottom left, our frames per second is 60 frames per second, which happens to be the refresh rate of our screen. And we've chosen the default for chops to be following the frames per second of the timeline, this timeline down here. So in 1 second, we'll go from one frame 1 to frame 60. Wow, that was pretty good. Won't do that again. Yeah, so it goes up to frame 60. This timeline's 10,000 frames long. I usually don't care because we just look at time continuously. But in terms of chops, they all have a beginning and end time internally. So because it's set to 60 frames per second, after 1 second I get to 60, frame 60, and that happens to be time code 000. This is 59 frames because time code starts at 0000, and 59 would be corresponding to frame 60. Therefore, you see that correspondence of 4 seconds, 240 frames, 240 samples long, so it's all kind of jives together. Now if you look at audio, the story's a little bit different.
Save your work again and save this.
Yeah.
Everyone had it.
File, save it out. Okay, let's look next at what we were looking at earlier with Ben, the noise chop. So put down a noise chop, and it's more than 1 sample long. It's if you middle mouse click on it, it's actually 10 seconds long, and again its default is 600 frames long, 600 samples long. The way the length is set on these chops, a lot of them, is via the channel page. So if you go to the channel page here, and for our purposes, let's just set the end to be 3 seconds long instead of 10. Again, middle mouse click on this, you see its length is 3 seconds. Now it's 180 samples and frames long, and that's because the sample rate of the chop is set to be 60. So it's blue, which means that's an expression there. So why is that an expression? It's because the default sample rate would be this timeline sample rate, which is this thing down here. So that's 60. So it's kind of kept in sync. So if I happen to change my project to be PAL 50, that'll change to 50, and this will be still 3 seconds long, but it's only 150 samples and frames long. So they're kind of interrelated with each other. If we make this a little bit wider and click on Viewer Active, we can go and see the samples individually. So do that, and then right-click on the graph and select, there's a thing down here called dot per sample. And okay, so yeah, right click here, just pick dot per sample, and it will give you a dot for every sample. So the hotkey D, turn it on and off. So often you really want to see how many samples there are. Examine a channel in detail. And then you can use your middle mouse button to zoom and zoom in and out, make it the graph higher or lower. It doesn't change the output, it just changes the view of it. And you can use your left mouse to scroll, just like that you do in other viewers. Okay, so if you counted all the samples, yes, you'd see there'd be 150 of them. So let's go back to turning this into a timeline with 60 frames per second, which means 60. And if I wanted to, I could say, I don't care about the timeline here. I want to make my sample rate 1,000. And whoop, I'll just go here, make it 1,000. And I'll get 1,000 samples, even though it's still only 3 seconds long, 180 frames long, and now it's 3,000 samples long. So now where that comes into play is audio. So let's look at just the audio file in. So put down an audio file in. Oh yeah, I'm not playing forward. So I actually paused my timeline here. So I'm going to click on it to make it go forward again. So we can either just pause it or lock it. So let's see, why don't we just lock this? So click on the lock flag, and it'll just freeze your data and not read anything in, and it'll be constantly outputting exactly this. If you attach a null to it, it will show the same thing. And is that okay? And then if you go to middle mouse click on the audio file in, you'll see that you have a small amount of time. It's 0.03 seconds, and that turns out to be 2 frames worth. And it's 2 frames of time, and it's actually 1470 samples long. And so the sample rate of this thing is 44,100 samples per second. So the audio file that it's reading is the WAV file, which is that MP3 file is at 44.1 kilohertz, and that makes it that many samples if we're looking at only 0.03 seconds now. So often you want to change from the audio amount of data coming in to something that's lower frequency, so you can resample it to a lower sample rate. There's a chop called resample.
All of our machines show the same graph. Is it not? It's not generated randomly.
Good question. To answer your question quickly, your noise looked all the same because there is a on the first noise page there is a seed here, right? You can change the seed and have different, so you can control it. If you always want your file to set up with a certain noise pattern, you can just set the seed and don't change it. If you want it to come up with a different noise pattern every day, then you set the seed to be the day of the year or something like that, right? You can use a clock chop to get the day of the year, CL. You use this day of the year, year day 24 here, and use that as your seed. So for instance, I can go from here, take the year day and stick it into the if you drag if you're exporting and the parameter isn't up here yet, you can put your cursor over the node and just wait a second, and it'll pop up its parameters after a second. And so I can put the seed there and export to that and go back to this thing. So now my seed is 24, but tomorrow my seed's going to be 25. Right? Does that make sense? So you can really control your randomness. Yeah, so I'm looking here. I want to export to this one. Wait, got it. Export there. Or oh, no, I meant here. Wait a second, it switches. So it's as you see, the green border around the node changes after a second because it'll select that thing. Okay, so back to our audio file. And so here we have our audio chunk that we just frozen in time at 0.03 seconds. And that's a lot of samples. And the resample, when we resample it here, we're resampling it to 60 samples per second. And it's now still 0.05 seconds now, because that's rounded off. But it's only 3 samples long. And if we go to Viewer Active and press D for dots, we can see there's only 3 samples here now. So we converted something that was this very poorly to this. Okay, so that's good. So turn the time slice off on the common page. Okay, so enough said. Let's do a couple more things. Okay, so I'll tell you my secret. My cheat sheet is in a different network. So go up to Roots. So hit the house up here, which is Home. And on the right side of Chops, there's Chops Ref. So go into that network, roller wheel in. And if I had another 2 hours, I would be teaching all this stuff down here. But so anyway, this is the network that we built. There are these other examples that I wanted to illustrate, but we don't have time to do it. This one uses the lookup chop, which is if you turn this button off, and you can trigger. You basically have a shape, and you want to just trigger that shape at certain times when you hit a pulse. So it'll just start it. So it only does the motion when you hit the button. There's this other stuff related to this. Okay, so that's what we just did. Oh yeah, this is an example. I guess Ben kind of covered it of using a speed chop to drive speeds of waves, LFO. So the low frequency oscillator, its frequency is driven by the slider. So often you want to regulate the speed of things, and it's an oscillator. And also another important thing is you'll see later as well the use of chops in connection with panels. So I think Ben covered this a little bit. When you have a container, this is like a container component, although there's nothing in the user interface, you still have a whole slew of channels coming out which are related to the mouse position and the buttons of select. You see the select up here, left, middle, right. And even when you just roll over or as you're dragging things, if you hit the control key, or the shift key, this channel comes on. So you get all this information out about what you're doing when you're operating a panel. And in this case, U and V, these channels here, are always 0 on the left and 1 on the right. So you can see the U and the V going from 0 to 1. So that's used very frequently just to contain your user interaction within a panel. The mouse chop that we fooled around with before, it applies to no matter where your cursor is in what panel, whether you're in TouchDesigner or not. It'll always be going 0, -1 to +1 across here. But often you only want to look at values when you're clicking or moving over a panel. So that's a very important one. And also the this is DATS. We'll look at that in a sec as well. And so also wanted to use another one for doing stuff with keyboards. Yeah, different ways of shaping things when you have keyboard input. So I have a keyboard chop here, and I have 1, 2, 3, 4, 5 that I'm just running my fingers over. And this just all different ways of altering the shape of things using just a filter or a lag chop, or a trigger chop like we just saw. or just counting things. So I'm just counting the number of times I hit the keyboard button. Under Dialogues, bring up Explorer, and that brings you up in the folder where this TOE file started. So in here there's this component called, and you can put it anywhere, component called Nanji desu ka, which means what time is it, and just drag that into anywhere onto your network. Okay, everybody got it up? Yeah. Okay. So so via Explorer, just drag and drop this onto the desktop. Okay. Anybody not have that?
Yeah, but my clock looks strange.
Yeah, so if you have your clock is both stretched and not centered, it's because of the resolution change between non-commercial and commercial.
Oh.
So
Okay.
just
Okay.
pretend like it's a dolly.
Is it still kind of visible though? Is it still visible in the view?
It's visible, just
Okay.
you're missing the 3.
3 o'clock is gone.
Oh, the 3 o'clock's gone? Oh, okay. So we'll go inside and.
Heavy punishment.
Oh. Okay. So, anyways, so with this thing, actually, so there's I had explanation of this is I saw a clock in New York City in the 1980s that did crazy shit, and I wanted to emulate it since then. And I'll explain to you what I mean then. So you, if you just press the 4 key on your keyboard, put your cursor over the thing, and press the 4 key, and then click your mouse on the left side, or okay. So you got stuff going. Okay, what's that? Press 4 key and just click. Yeah, just press it once. Okay, now press the 2 key. Now press the 3 key, or the 5 key for that matter. So.
And that's why New York is how it is now?
Yeah, so everybody's late in New York.
Yes.
Okay, so this was actually a physical clock with real electronics that was just part of an art thing in Soho, and I was kind of like taken aback by it, and so I tried to reproduce it about 10 years ago, and I couldn't with the old version of TouchDesigner, and I just actually reproduced this last night. So this got tons of chops in it, and if you go inside it. Here's my explanation on the right, but it's all coming in. There's 8 different effects, and there's a keyboard in chop here on the left, and so it's basically using the first 7 buttons. Actually, it should use the first 8 buttons. First thing to do with the keyboard chop is to actually change the number of keys to 8. And if you just press the 1 key or 2 keys and so on, you end up with the channels going on. Now you notice this logic chop over here. So what I wanted was that the key value stays on after I let go of the key. So after I let go of 3, 3 goes off, but the logic chop sustains it. And that's because the logic chop is set to act as a radio button. So there's a lot of channel pre-operations. So the stuff coming in is usually 0 and 1 channels, and you can invert, toggle, So you can do a whole bunch of like operations on logic data without having to code. In this case, I wanted to take all these keys coming in and turn it into an integer. So the fan chop is really useful for taking multiple logic channels and turning it into a single integer. So if I press the first key, 1 goes on, fan goes to 0, and so in that case I had changed the fan chop to fan in, fan multiple channels into 1. And then if I wanted to, from here I can take fan and fan out. back out to the original channels with different names. But yeah, so anyways, this is a way of getting from multi-channels down to one and then back out again. And in this case, I had I could have exported this to my switch, because my switch is basically switching between all these different behaviors. And I invite you to actually go in and look at some of the ways these things are made. Some of them are just using ramps and so on, and some of them are using steps, quick pulses. One's using just completely random, random numbers somewhere. Oh yeah, down here, all random data. So, and again, I invite you to have a look through this, and then the data comes out at the end to a thing that scales it to degrees, and then that's sent to channels within the clock object, which are just these, these lines and so on. So these two channels export to these two SOPs, and they're merged together, and that's what's used for the rendering of the thing. So, okay, any other channels? Any other questions? No? Okay, so let's go on to quickly go through some things in DATS.